Hello.
Yes, sir.
Good afternoon.
Good afternoon, sir. Good afternoon.
My name is Swami. I am from Ingram.
Okay, okay. Swamiji, you have joined slightly early. You are
Yeah, I joined around 2 minutes before. I've
no
been
issues.
told to join at 3 o'clock.
Yeah, yeah, no issues. But this I will just abhi session has not started yet.
Uh-huh.
It's 3 to just 5 minutes I will take, and then you can start presenting.
Okay. All right, sir. No issues. No problem.
So, thank you.
Yeah, sure.
ये कहाँ से आ गया? ये किसने? ये तू कर रहा है? ये कहाँ से आया?
शेयर नहीं कर रही।
अरे मारू, शेयर तुमने किया क्या?
नो सर,
तो स्टॉप करना, यहाँ क्यों शेयर कर रहे हो?
मैंने नहीं शेयर किया।
देखिए नीचे किसका है ये स्क्रीन? ये शेयर हो गया है गलती से, ऑफ कर दो। स्टॉप करो यार।
स्वामी जी आपकी स्क्रीन शेयर हो रही है।
हाँ, मेरा स्क्रीन शेयर किया ना मैंने।
अच्छा स्वामी जी, आपने किया क्या?
हाँ जी, मेरा स्क्रीन शेयर किया मैंने।
अरे नहीं सर, अभी 5 मिनट रुक जाइए।
हाँ, ओके.
Hello.
When I'll invite you, na, that time you do this.
Hello.
Okay, I stop.
Okay.
Not a problem.
Just for the testing, it is okay.
All right, okay.
Hello everyone. Am I audible? मेरी आवाज आ रही है सभी को?
हो गया। बता दो मुझे।
यस सर।
हेलो। हाँ, मेरी आवाज आ रही है महेश्वरी जी आपको?
जी सर, बिल्कुल।
Okay, so should we start?
See, sir, I don't know who all are have to join.
No, most of the participants have joined. So, are you? आप presentation के साथ ready है ना आपने?
Yeah. We
Okay.
are ready.
So we are now going to start the webinar. I request all to please mute themselves. Hello. Good afternoon to all. Respected senior officials of Indian Railways, SSCs, JEs of SNT department, and all other participants from various railway units. I welcome all on behalf of Chemtech. Today there is a webinar organized on IP MPLS technology at Chemtech Gwalior, in which the presentation will be given by Mr. Maheshwari ji. He is a director of Messrs. Maheshwari Computers Private Limited, Indore, and their engineer, Mr. Sachin, which will be followed by Mr. Anand and Mr. Bhatt from Messrs. Nokia. So now I will request Mr. Maheshwari ji to start with their presentation. And before that, I will request all participants to please mute themselves. They can ask their questions in the query session after the presentation. Thank you. Carry on, Maheshwari ji.
Yeah, thank you for giving such a big opportunity to us. We are now currently working in railways from last about 3-4 years, and let me begin. There is one amendment. Mr. Swami is there, is a professional trainer. He has also joined us, so he'll be giving after the brief introduction. I'll just give about my company after that. Just few slides for our company, so that just a feeling like what our organization is. We are Maheshwari Computers Private Limited, Indore-based organization, and this is like just a slight run away. We are into almost all IT infrastructure solutions, right from the defense, and we started our career from first order of 1998 from Army War College. It was a LAN order, and currently we have more than 100 plus people, and of course some just to communicate our vision, mission, and all. Let me just shortly tell you that we are a 30-year-old organization. I myself is a BE Electronics and Telecom, passed out from Indore only, and I have a very wide experience in designing the solution, in making the RFPs, the tenders, the execution, and many other aspects of the IT infrastructure in terms of audio, video, in terms of telecom, digging, laying, everything. Like we are up to, like, railway has given a chance to install now Excel counter also. So a lot of things we are doing, and of course MPLS we have established about 5 years back in an Army Institute with P and PE routers. So I'm fortunate enough to get this such a big opportunity to present our company in a different manner. Like we have done MPLS, we have done NOK vehicles, we have done mobile technology lab for Army. After that, we are doing a lot of projects for railways, telecom, and signaling. So all this combined together, we know SDH, we know STM. So this is the very important aspect from a small company like us, who has got this manpower currently available with us in terms of Sachin, who is a very experienced guy. So we can cover up the solution in such a manner that it will be beneficial for the railways as well as for the national security and the future, what railway should go on, because this is a very hot topic currently. MPLS, we are already in discussion with OEMs as well as senior DSTs and other people. So just to brief some of our slides, these are some of the railway projects which we are doing. Just few are mentioned. We are in fact doing a lot of more projects, like we are doing Western Railway Mumbai GPON, then a lot of RailNet projects in establishing LAN. Other than this PA system or Excel counter, we are doing for Western Railway. And these are some of the projects which we have already completed. Just a brief diagram of the project which we have executed about 5 years back, 6 years back, MPLS. Matlab that this is slightly briefing which Sachin will take over later on. But this is all we had already implemented in a lab environment for the routers and this various labs connected to demonstrate the student MPLS, and we had trained people on the MPLS that time. It's a very, and it was very high-end routers which were taken into that solution. So this was something I just wanted to show you that yes, we can help out overall to help ourselves as well as the nation to build such a network that Indian Railways is really proud, and whatever we can contribute, we are ready to contribute. This was one of the project which was very unique which we have done. This was the LT technology project which we have done in MCT Maho, Military College of Telecommunication Engineering Maho. This project was 10 crore value, and we have established almost all the things at that time which were supposed to be like SDR and all these things. I think the people who understand this terminology, they can know that what is E node B and what is BTS and all that. So even the software was 2 crore worth of software was there in this for the running the BTS. But on this, we have trained for 3 years to the students. So our people are like that, you can understand. This is something very unique project, which is again having an impact in today's scenario also. These were two vehicles of 1.5 crore each, wherein both the vehicles were connected by radio, STM radio, and the vehicle was built in with furnitures and everything, and even the UPS, the generator, L2, L3 switches, IP exchange, and the students were trained on this on an open OFC outside both the vehicles. 40 students used to train for 5 kilometer distance, and they used to communicate everything. And this again, we had helped army to design this solution and finally sell it also. So this is our just a brief background, like what we can do and what we can do just to make you interested that we are ready with railways to design MPLS in such a way that you get the best pricing as well as the correct solution. So let me just stop here, because Mr. Swami has joined as a very professional trainer, which I have organized especially today for you. So just he has got very short time and he's a very senior guy in MPLS. So Mr. Swami, are you hearing?
Yeah, thank you very. Yeah. I'm hearing.
Yeah,
I'm hearing.
now
Mahesh.
now you can come. I'm just stopping my sharing. How to stop? Okay, okay, got it. Yeah. So Swamiji,
Thank you,
you can take
Maheshwari.
over. You have limited time, so I would like you to finish off first. That he will brief basically what MPLS is. I think it will be a very useful session at this moment for railway people, because we are still in the initial phase. Railways is still in the initial phase to understand what MPLS is. So
Uh,
before the Nokia takes over, I think Swamiji should share some their experience. Thanks.
Yeah, thank you very much, Maheshwari ji. So, very good afternoon to all the listeners, who senior professionals who are joined this particular webinar, short webinar, where we would like to give you some brief idea about the MPLS. It's a, even though it's a very big course, but we wanted to give you some touch upon it, where you can understand the concepts. In order to understand the concepts, I just give you some idea, some example where you can get in easily. Say, for example, if I wanted to travel to Delhi, now I don't have to buy my apartment in the Delhi to stay for a 3 days or a 4 days or a 5 days. Correct. Generally, we don't do that. What we do is that we generally go to the Delhi because it's a new place to you. You just come as a visitor, so you prefer to hire some services such as a hotel and stay there for 2 3 days. If you don't like it, you change again one more hotel. If you like it, you stay in the same hotel and you finish the task and you come back. Very similarly, in the legacy systems, we used to establish our entire network with reference to the ISPs, where we used to build the VPN networks, point-to-point networks, many networks we used to be in a legacy style. But with the arrival of MPLS technology, the service providers are now taken care of providing this service. So I do not have to invest my money in any infrastructure except connecting myself to this network. Now the service providers will do all the backend network, the point of presence, whatever, wherever they have a networks, they will do take care of it. And then we only just join and we will just take the benefit of the particular infrastructure at a much more cheaper price. The price factor is one of the important part of this technology. Now, technically, this is a basic theme. That means what I can use someone's service to deliver my business results. Number one. Now, what is so great about a MPLS? Normally, we are using the legacy systems in earlier cases. So, why the MPLS is? I have a few slides to show you, around 10, 5, 15 slides, which I've got something to show you about what MPLS works and how it works. See, MPL is basically, it is called a multi-protocol label switching. The reason of existence of the MPLS or invention of the MPLS came out with a concept called whenever I am routing a package, I have to look into the routing table. So looking into the routing table is a tedious process if the traffic is too heavy. Now we will have to find out like how I'm going to make sure this traffic is being passed on in a quick and fastest way. So we got something called an MPLS concept here. Like for example, in a school, you have 100 children in a classroom. So instead of remembering each one's face, you just give them some label number 1, 2, 3, 4, 5. So you can say number 1, please go out of the class. Number 2, please go to the library. Number 3, please go to the playground. Something like that. You do that. Okay. So we we just label them and we call with that labels. We don't have to find out his credentials, his name, his roll number, where he's located, what he's doing. This is not required because this is the fastest process. So similarly, in MPLS networking, whatever the incoming packets are there, they will be basically labeled. So the labeled packet need not go and find out in the routing table what is the destination IP address. That is one of the biggest advantage of this. So you can see that uses labels to append the packets. MPLS packets can run on any other layer 2 technology such as a ATM, FR, PPP, POS, Ethernet. Not only on the layer 3 services or any of we are using it out, but MPLS one of the greatest advantages that we can have a layer 2 services as well as. On layer 2 technology can run over the MPLS network. So this is you can see the diagram, one of them. This is my network infrastructure. This is my MPLS. On the MPLS background, on the network, we can run the VPNs. We can do the traffic engineering. We can run IP plus ATM switches. These are the asynchronous switches are there, which are not very popular, will not become very popular in the world. Uh, we have currently almost, I believe, 90-95% of the population is fully covered with Ethernet in the network fleet. But we can still have the IP plus ATM on this one. Then IP plus optical or any transport over a MPLS. These are the type of the services where I can carry on the MPLS network. Second is, it is basically a packet forwarding concept. So I'm going to forward the packet based upon the label. The example I gave you the students. You are having 100 students. Okay. You don't know whose name. There's no time for you to note down the name and call individual names, correct? And then tell them to go in the classroom. But instead of that, you can have a badges. Labels are given 1, 2, 3, 4, 5, 6, 7. Like, okay. In the marathon also you have a labels, at the back of the t-shirts 1, 2, 3, 4, 5, 6, 10, 100. So the winner cannot be identified by his name, but the winners are identified by his number initially. Then you identify what is name and all. Very similar to that one. So label assigned when the packet enters the network and labels inserted between the layer 2 and 3 headers. Okay, so we have a layer 2 is my data link layer and layer 3 is my network layer. So it is a halfway between the network layer and data link layer. MPLS nodes forward packets based on the label. Okay. Separate routes from the forwarding. So routing uses IP addresses, which is a very tedious process, whereas forwarding uses the labels. Okay. Now labels can be stacked. I can stack the labels, and then based upon my requirements, I can keep on pushing out the labels onto the packets and then forward it. This is a internal structure of one of the packet, how the label looks like. You can see the label here. It is a 20-bit, so I can have a label number. So the labels can be used over the Ethernet, that's the 802.3, or I can use it on the PPP links. And these are some technical internals. I'm not going into details of this one, but I'm just explaining to you how the labels are attached to your particular packet. Okay. So when the packet arrives at me in the one of the router, the incoming router, the router immediately takes the label and stack the label to that particular packet and forward into the MPLS network. Then this packet will be forwarded into my various MPLS, uh, what do you call, routers, which are part of this one. And finally, it's sent it to the outside. So while sending it to the outside, it will take away the label and then again give the destination IP address and forward it to the destinations. So only these labels are applicable in your MPLS network. I'll show some diagram to you. Maybe I'm having this diagram here. This is your, this is a diagram. You can see that. See, this is a diagram. You can see the one of this is. See, this is my edge routers. Okay, edge routers are basically the routers which are connected to my customer, and these edge routers have got a capabilities to remove the label for the outgoing traffic, add the label while incoming traffic, and then this one will pass on to my provider's network. This is my provider network. You can see in this one. Now, providers networks are they know about the MPLS technology. So the moment when the packet comes, they see the label on the particular packet, and they have a table. There's a forwarding table will be there. So they go and match the forwarding table and pass it on. They will not look into the routing table, and that's how we gain a lot of a what do you call, efficiency in terms of the forwarding the traffic. And finally, when I'm going outside, suppose uh, here you can see the C control network, correct? From left side to the right side, I'm going here. So the packet is entered into the edge router here. From edge router, this goes to the my MPLS routers, which we call them a provider router. The P means a provider environment. This is called a customer environment. So the provider environment it will enter, and finally it goes into the MPLS. The packets are forwarded. Finally, I go to my edge router, and edge router will remove that particular label and forward this to the destination point of it. So in the entire course of the transaction, we never talked anything about the IP address. So this is all happening on based on only labels. Okay. So this is the idea of what uh, we're talking about the labels. So you can see that there is a PPP label. These are packets. Okay, PPP, Ethernet, frame relay, ATM. That means I can have a multiple technologies on the layer 2 where I can keep the labels here. So there's an IP header, there is a data, and finally this bottom one, when we are talking about a cell, this is goes to the ATM. So we're not talking ATM, we don't use it. So let's stick ourselves to the first diagram. So this is my frame, layer 2 frame, where I'm having a Ethernet frame, where I'm stacking this label. You can see I'm putting this label inside this. Okay, this is called label encapsulations. Then in terms of the applications, we can have generally today virtual private networks are becoming a very popular applications, VPN networks. In the VPN networks, we have two categories. One of them is a layer 2 and second is a layer 3. Now, layer 2, you can think something like this. On the MPLS networks, you are having a virtual switch from source to the destinations. where I don't do any routing, nothing, because it is a layer 2. I'm simulating the layer 2 service. Okay. The switches. In a switches, normally we use layer 2 the MAC addresses. I don't do anything with IP addresses. So you develop the similar kind of an environment layer 2 VPNs. We call them as a layer 2 VPNs. So we develop the layer 2 VPN, and there the packet movement is only happening because of the MAC addresses. At the same time, the MPLS also supports layer 3 VPN, where I involve the IP networks. Okay, here you can see that here. L3 provider has no knowledge, has a knowledge of the customer routing, and L2 provider has a no knowledge of the customer routing. Okay, then it also supports you something what is called this ATM. I'm just skipping the ATM. You can see that MPLS VPN layer 3. So private connectionless IP VPN, it is having a outstanding scalability, lot of scalabilities. You can just connect the stuff because MPLS network is taken care by your service providers. So multiple QS classes, secured support for the intranets. Okay, these are all features. I'm not going more details of it, but I'm just giving you some important features of this one. Now this is my IP packet. You can see that it determines a VPN label. It determines a, PE router IGP label, and then forward this stuff. Okay, this is a layer 3 VPN. Now, why provides like a MPLS VPN? Because this is a earlier one. This is my legacy VPN networks. Okay, build ones and sell ones. That means only dedicated networks were built it for me. Then that network I cannot scale up. But today you have a build once network at the back end, and you can connect. You just have to connect. For example, in Dubai, I've seen that Etisalat. So Etisalat is selling this MPLS network services. Tremendous success for them. What they use, they charge few dirhams to the customer, and then what they do, they only have to connect via DSL line. Via DSL, they connect to the MPLS circuit. That's finished. No more money. Just pay the fixed cost and then use it. Okay. So cost wise, it becomes a very uh, affordable. So this is how what we talk about. So on a layer 2, you can see that here. All layer 2 frames are moving between the two networks from one end to the other end networks. So one of the advantage of this layer 2 network is that I can launch any type of the applications on the top of the L2. Any network applications I can launch. Maybe it's a voice, maybe it's anything, because it's a switch. Like in a switch, you can connect the IPv phones, you can connect the phones, you can connect your normal laptops, you can connect the servers. Okay. So that is how you can have a something like the layer 2 here. So reduce the cost, simple provisioning for the L2 services. All right. Now it also supports you the traffic engineering. T means a traffic engineering. So what is the traffic engineering? It will optimize the link utilization. We specify the path by the customer or class. Then balance traffic load. We are trying to traffic, doing the load balancing in the traffics. Okay. So that's one of the traffic engineering, which is the inbuilt feature of the MPLS. These are some components of the MPLS. We required one routers, which is called edge label switching router, and we call it a label switching router. Edge label switching router, I told you the function. It will add the labels while incoming packet and remove the labels while outgoing packets. Label switching routers are the service providers routers which are capable of understanding the labels what has been put by the edge labels. This is some components we have, I think, talked about it. The basic function of the components is either forwarding and the controlling. That's it. It just forward. Just forward. I mean, MPLS means just forward. That's a simple way to understand it. I just forward without going into the routing table. Normally, in all the packets in the networking, they see the routing table, then they forward it. Okay. I think that's. I believe that has given you some idea to you about what is
Swamiji,
MPLS.
it was a wonderful session you have taken, and I just want to inform the all the railway people and the senior officers that these services for training is also available with us for providing any 1 day, 3 day, or even hourly basis training. Whatever you want on MPLS, we can offer that. That was just a demo from Swamiji on my personal request and with our distributors in line. Thank you, Swamiji, very much.
Thank you, Maheshwarji. Thanks to all of you.
Yeah.
I'm sorry, I think I've taken less time, but okay, I've tried to give you
No, no,
some
no issues,
concept
no
of this
issues,
one.
no
That's fine.
issues, no issues,
Thank you
no
very much.
issues.
Thank you.
Thank you.
Thanks to all of you.
In your
Really.
short time, you have given enough.
Yeah.
Thank
Thank
you.
you very much, sir. Bye bye.
Thank you very
So,
much.
yes, sir. So now next, let us come to slowly now our session, we are moving towards the railway requirement. So let us first go to the RDSO solution by Nokia, and then we will conclude by our expert engineer Sachin for the railway and the MPLS integration, and after that we will go for the queries. So I'll request Anandji to please share their slide if possible, or else I will share. Anand from Nokia and Bhatt sir from the Nokia. The team is here.
Right. Thank you, Rajendra ji. First of all, thank you everybody who are part of this webinar. I welcome you on behalf of Nokia. Myself, Rushit Shah. We both are from technical pre-sales, and we have been working very closely with RDSO and also Mr. Bhatt, who takes care of the account management from Nokia side. So I'll try to share my presentation. Allow me a second, please. I hope I'm audible. Rajendra ji, if you can confirm.
Yeah, sure. Very much.
Yes,
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 yes.
I've got it.
Thank you, sir. Thank you. I'll just try to share my screen. And again, I would like a confirmation if you are able to see my screen.
It's visible.
Fantastic. So, right, sir. So, sir,
Yes, sir.
I would like to start with the vision that the Indian Railways has rather with respect to IP/MPLS as a chosen technology for being future ready. I would say, which probably comes from the idea that the current generation, the current install base that you have on the SDH side, uh, it technically is a dying technology, or is already a dead technology. There are no investments happening in that technology, but yet there are services which which are deployed and would be there, the SDH based technologies that would be there for few more years to come. We do see certain applications which are there in the railways which are moving towards Ethernet based architecture. So the whole idea behind IP/MPLS was that it is not only forward future proof, but it also has backward compatibility with the legacy world. I'll try to on my on this slide you can see that the whole idea was to move the legacy interfaces from the TDM SDH world towards the IP/MPLS network based technology, and of course based on the specifications that were laid down by the RDSO. Now, the RDSO, there's a reference to the document STT TAN IP/MPLS version 2020. So we closely, I mean, we amongst other leading OEMs, Nokia also participated and worked very closely for almost, I would say, 1.5 to 2 years to formulate the specifications under this document, which satisfies the requirements laid down by the Indian Railways. And then it is kind of handed over to the railway divisions to use this document, this specification and look for modernizing the transport infrastructure that you currently have. The whole idea of IP MPLS, like what Mr. Swami also, in last few minutes, he was talking about certain terminologies like the LSR, the LER. So the whole idea is that, all the wayside stations will have IP MPLS routers, which are termed as label edge routers. Label edge routers. Now, label edge routers, typically, what Swamiji also explained, are typically which are taking the service in, right, and encapsulating them onto the MPLS layer, and then carrying it forward towards the next router and the next and the next, and finally, the far end destination label edge router would again give back the same IP payload or the packet to the application where it is destined to. And then there are certain there is another functionality called LSR, which is called as label switch router, which is nothing but high capacity, or a highway, a data link highway, that is which is terminating multiple LER based rings, onto it, and then giving them a reach for covering farther distances. And again, their function is only to switch, not to look into the packet to make a forwarding decision, but to look at the MPLS label header, and then making a decision what is the incoming label, what should be the outgoing label, and the outgoing interface from that label switch router. So the whole idea was to have a network, IP MPLS network, based on both functionalities, the label edge routers and the label switch routers. Uh, so this slide kind of gives the overall theory of what are the key functionalities of the label edge router. So typically, the label edge router, from a IPMPLS based network for railways, is supposed to is supposed to act as an aggregation router for terminating not only the Ethernet services, because you may be having certain applications which are Ethernet based, but also you would be having certain legacy services, maybe SCADA, maybe legacy voice which runs over E1. So the edge router should definitely have the capability of terminating legacy TDM services also, right? So basically TDM interfaces. So typically, LER has to support both the TDM and Ethernet interfaces, because you have some legacy, you have some Ethernet, and although moving forward, applications are changing toward Ethernet itself. And from a functionality standpoint, LERs have to be located on all the wayside stations as well as the junction stations. The the LSR, on the other hand, will be used to create high speed 10 gig carrier Ethernet WAN backbone. And because on the junction, the wayside stations are anyways going to have the LER, which have the capability of terminating both Ethernet and TDM. The LSRs, which are on the junctions, uh, along with them, there would be one or more LER routers which are going to do the TDM aggregation for the legacy applications. Um, I'll move on. So typically, based on 2 years, 1.5, 2 years hard work of defining the specifications, these are the kind of specifications on a very high level that were defined by RDSO. uh, it and then there were three variants. If you look carefully, there are three variants of LERs, and the best part is that they have to have the capability to grow organically on the same box. So the router that you deploy on day one should be able to upgrade, should have the upgradability path to the configuration specifications that have been mentioned in LER Max 1 and then LER Max 2. So typically, all the variants are supposed to be are supposed to support minus 48 volt DC in a redundant form. The routers are supposed to have fan tray, are supposed to have control plane redundancy, and also field replaceable units, in the sense that if you have to do some maintenance work, so you don't need to power down the router, because the network cannot afford, I mean, railways. So what Swamiji, I would like to point out one more thing, with respect to MPLS. Swamiji mentioned about MPLS, and the examples that were laid out by Swamiji were more from a service provider kind of environment, where they they capitalize on the MPLS network. It's the source of revenue for them. For railways or for any other vertical industry, be it power, be it oil and gas, be it transportation, it is a critical network. It is a network, so it's not a revenue generating, but it is a critical network which keeps the main business of that organization to function in a continuous way. Having said that, that is the reason why, the choice of the equipment that has to create this MPLS networks are to have all these critical functionalities. From an interface specification standpoint, the LER are supposed to have, so the minimum configuration that the RDSO has defined for a label edge router is two 10 gig interfaces running on enhanced reach optics. One thing that we need to keep in mind is that the vision is that, because railways has abundant fiber, running on the track side. So for reach to connect one station to another station, they have chosen long haul optics, which can be installed directly onto the routers. So this really helps to cut down on your underlay transport cost. So you don't need to deploy any kind of SDH network or a DWDM network to connect two stations over IP-MPLS routers. Apart from that, yes, there are going to be some gigi interfaces, both optical and electrical, to support connectivity with the other elements which are there on the station, on the wayside stations, and also having events to support the legacy applications. Say, for example, maybe some signaling is required. So the best part of IP-MPLS technology is that it not only gives layer 3 VPNs or layer 2 VPNs, it also supports circuit emulation, right? So circuit emulation is like, if you have a voice, legacy voice that you want to carry from one station to the junction, maybe you can you can you can encapsulate, or you can emulate that end-to-end even over IP-MPLS. And this has been proven. I mean, MPLS is almost like 2 decade old technology now, very matured, very matured. And I have personally, in my career, I have seen operators converging their segregated networks, their legacy voice network, legacy data network, ATM network, or a frame relay network, all in all onto a converged IP-MPLS network. This reduces a lot of opex and capex for anyone. I mean, be it a service provider who's using that network to generate revenue, or for any critical service provider like railways, to reduce capex and opex expenditures. So MPLS helps you to converge voice, data, legacy, everything onto a common platform. um, Another aspect was that these systems have to have to support extended temperature range, and the capacity that was envisaged for this through this exercise with RDSO was that it is good enough to have label edge routers which can support 30 gig capacity and 80 gig capacity for the label switch router. Moving on, So like the previous slide which talks about the minimum configuration and the expandability to max 1 and max 2. The next slide is kind of uh, uh, giving it in a very diagrammatic fashion. So typically LER, like I said, on day one it should support two 10 gigs, 16 E1s, and 8 gigi interfaces, gigabit ethernet interfaces, out of which 4 are copper, 4 are optical. The 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 directions laid out by RDO specification was that I can, without changing the box, without changing the chassis of the router, I should be able to upgrade
What
that
are you making
16
now? There.
uh, without without changing the chassis, I should be able to upgrade the 16 E1s to 32 E1s, and or I should be able to add a channelized STM, two ports, along with the 16 E1s that I have on the day one. So this flexibility was asked in the specification, but considering that you don't need to change the box at all. Once installed, that upgradability should be there. And not only that, further directions were given that in case a station A which needs one more LER, that can be added by adding a LSR and adding one more LER on that station, maybe upgrading it to a junction station. So this is the typical connectivity that was envisaged, that a junction would always have a minimum one LER, and of course LSR, to connect in different directions to different railway routes that you already have. um, Another aspect of this, and this is the typical schematics of how your VPNs, which are already there, or the new VPNs that would be carved out in this IP/MPLS domain, how would they, get connected to, so say for example, you have UTN, you have FOIS, you have RailNet, you have CCTV, etc. on station, which are getting aggregated onto smaller, edge routers or LAN switches. They can uplink to the IP/MPLS LER router, and then the service can be carried over the OFC network, all the way to the destination. Moving on. So, I mean, there are certain things that I would like to again, re-emphasize, that IP/MPLS is definitely, it's the future. It is a very mature technology. It is the future, but it also has backward compatibility with legacy services. This is what this slide is trying to highlight. Moving on, like Swamiji also mentioned that IP/MPLS as a technology is transport and protocol agnostic. Having said that, what I'm trying to say is that MPLS can ride over SDH, can ride over. So basically, you can connect two IP/MPLS routers over E1, over STM1, over Ethernet, over ATM. Media could be anything ranging from fiber to copper to microwave, and IP/MPLS helps to carry services ranging from IP, which is maybe a layer 3 VPN. Ethernet could be a layer 2 VPN. ATM ATM and frame relay are again, two. These were like, way back 10-15 years, they were mainstream technologies. Now hardly anybody uses it. The last customer I know in India was probably defense, which anyways they are not using. And then of course the TDM. Uh, Another beauty of IP/MPLS as a technology is that it is topology agnostic. So you can have a network in a ring, you can have hub and spoke, star topologies, or a full meshed architecture, and you can insert a new node without any issues, without disturbing. You can add links, you can add a node, insert a node in your topology without disturbing any of the services which are already running on the on the existing topology. uh, it is service agnostic. Like Swamiji also mentioned that you can emulate services, legacy services, something like for teleprotection, for SCADA, for signaling, for GSMR, using circuit emulation, technologies. You can emulate your LAN, virtual private LAN, for services like goose or signaling, basically signaling which is using Ethernet. You can create IP VPN services, uh, or the layer 3 services for your intranet, for your internet connectivity, for voice over IP connectivity, and also multicast. IP multicast is something which is not capable, which is not even a far possibility over SDH networks. And multicast is something which is used extensively by video surveillance, for video conferencing, IPTV, these kind of services. They primarily use multicast, IP multicast. And IP multicast really saves a lot of bandwidth, because it is like one to many, not one to one. Um, IP MPLS has all these kind of capabilities. It gives you better resiliency in the sense, you know I can cope. I mean, we can certainly cope with multiple failures. If the convergence will happen, because the IPMPLS has certain protocols, like there are some advanced protocols like RSVP and segment routing, which can look at, which can calculate the bypass routes beforehand. They know that my primary path is this from A to B, but in case something cuts, I can switch over less than 50 milliseconds onto a alternate path. And then I can, by the time by the time my next primary path is being calculated, I can continue serving the traffic from a detour path. And once a new path is secured, I will switch over seamlessly onto the new active path. And also, it provides, load balancing over, maybe I can have two paths from A to B, and I can load balance. I can send some traffic from path A, some traffic from path B to the destination. uh, I mean, with traffic engineering, I can know that my behavior on my of my traffic, of my critical traffic, or my voice traffic, or my data traffic will be always deterministic. I will know that at this time of the day my latency would be this. At this time of the day, my jitter would be this. So because traffic engineering, helps you to utilize certain unused section of the network. So if that is the case with native IP, you can't engineer the traffic. But with MPLS, you can always engineer the traffic in such a way that you can utilize your network resources in a very, very efficient manner. um, Multicast I already touched upon in my previous slide. Again, IP MPLS as a technology has the inherited capability of serving, uh, you know um, uh, point to multi-point kind of traffic, which typically are the critical applications like CCTV, video conferencing. These kind of services can be efficiently delivered over IP MPLS using multicast. Moving on, cyber security. Now, I mean, we understand that railways is serving, is the nation by allowing people to and freight to move from one point to another point, and in volumes. And this network, needs to be secured. So IP MPLS as a technology can provide cyber security at both layer 2 and layer 3. uh, Today's routers, IP/MPLS routers, they have inbuilt firewall capabilities. They have inbuilt NATing capabilities. Um, you can choose to run. You can choose to encapsulate. You can choose to sec- uh, not only the secure the payload but also the control plane traffic, which are like the routing information, the label information, um, uh, uh, you know on the equipment itself. um, Moving on. So so this slide is, I added this slide to give a confidence and give some comfort that the migration is not that you have to deploy IP/MPLS and then on one night you have to switch off legacy and move everything onto IP/MPLS. That is not the case. So say for example you have a legacy TDM based in network where your applications like voice, your SCADA, your E1 T1s and your other legacy interfaces which are riding over TDM muxes, add drops circuits. You can always uh, look at moving few of the you can always introduce an IP/MPLS layer into the network which can keep which where IP/MPLS can also ride on uh, the um, uh, the uh, the legacy SDH TDM, and you can start migrating your applications which are IP Ethernet native, and or by adding TDM cards onto the IP/MPLS label edge router, you can start migrating your legacy services onto the IP/MPLS router directly and bypassing the TDM muxes that you have. And then by the time you do that, you have already modernized your backbone from SDH Sonnet to IP/MPLS, Ethernet based IP/MPLS. So you can choose, you can minimize the downtime, you can migrate end service at the right time when you feel comfortable. So one thing which in addition, I would like to carry to cover is, the, I mean, the history of Nokia. So typically Nokia people, they related to, being a radio GSM, radio technology vendor. But Nokia, as a journey, we have had 2 decades of, IP innovation and growth. So it all started way back in 2000, where a startup called Timetra Networks was formed, which was later on acquired by Alcatel. And then further, when Alcatel and Lucent Technologies, they merged, they created a joint venture, Alcatel Lucent. And way back in 2016, 2017, 2016, 2017, Nokia acquired Alcatel Lucent. And with help of that acquisition, Nokia not on- in addition to being a radio mobile radio leader, they also acquired Alcatel Lucent's IP portfolio, optical portfolio, fixed line FTTH portfolio and all. So all in all, you know Nokia routers are typically nothing but Alcatel Lucent routers, what you would have already seen deployed in multiple networks. um, this is just a snapshot of what the IP networks division of Nokia now accomplished in 2021. We are doing somewhere around $2.7 billion worth business only in networks. We are number one in IP edge router globally, and number one in total IP routing, in Europe, Middle East, and Africa. Uh, in terms of customer base, world's out of the world's top 100 communication service providers, 99 of those customers are making use of Nokia IP portfolio. We have till date shipped more than 1.4 million routers. uh, we are not only serving the CSP and cloud providers, we are also, serving more than 900 government and digital industry customers worldwide. We, like I said, in my earlier slide, communication service providers, cloud providers, digital industries, and government. We are addressing the IP requirements, the IP data network requirements of all these verticals. Few examples of some few logos that I'm proud to show over here. British Telecom, AT&T, Verizon, Airtel, Vodafone, China Telecom. I mean, you name top 100 operators worldwide. We are there. One thing I should tell you is that, when you actually do anything on internet, right? You may be going to a website. uh, your packet from your computer all the way to the server in the destination network would cross a Nokia router. It will always cross a Nokia router. So, other than the service providers, like I said, we are serving more than 900 critical service operators. Government, defense, utility, transportation, oil and gas. Um, you know, uh, you know, in transportation, these are a few examples that you can see here: NCRTC, Dhaka Metro Rail. In utilities, few logos from India: BSES, Tata Power, Delhi, Power Grid. We are there. I mean, and these kind of logos, they are, using. For them, it is not a revenue. IPMPLS is not a revenue. It is their backbone. Their services rely on mission critical IPMPLS network. Um, ranging from teleprotection to SCADA to control and signaling, things like that. And just a brief, this is just a very, very high overview of the routing portfolio that we have. Out of this, typically, the 7705 services aggregation router portfolio is something that we have to offer to utilities and to railways, and for the mainline IPMPLS network deployment. We have IXR 7250 interconnect routers, which are Ethernet only kind of routers, and they are high capacity routers, right? Which can create the backbone, IPMPLS backbone for the Indian Railways. Apart from that, we have switching portfolio also, including high temperature DIN rail mountable LAN switches to IPMPLS capable routers within the 7210 service access switch portfolio. uh, and just a deeper view of the 7705, which can be used as the mainline IPMPLS network on the mainline railways network. We support legacy interfaces like STMs, RS232, V.35, X21, ENM, FXOFX. C3794 is a very famous interface for teleprotection used by power industry. We have, and these are all typically extended temperature range. They have inbuilt security features like network address translation, encryption, firewalling. They support synchronous Ethernet and 1588 V2, which is very critical for because so basically what TDM provides, all those features are provided. Time synchronization, temperature hardening, redundancy in terms of control plane. We have different kind of uh, different sizes of these routers depending on where to be deployed in the network. So again, what I spoke in the earlier slide, it is kind of documented here. This portfolio is fully featured IP-MPLS for layer 2, layer 3 services, multicast, legacy, migration from GSMR, Tetra, SCADA, signaling. It has support for harsh environments. EMC, EMI is very critical for Indian Railways. So these products are certified by various certifying agencies across the world. It has very rich set of quality of service features, which can give you, the same feel of, the SDH era, where when you commit a E1, nobody else can share that space. The same kind of experience can be given by APMPLS by the use of quality of service features, fully secured. Encryption, firewalling, network address translations are part of this particular, the routers which are falling under this portfolio. Very rich set of operations and maintenance for measuring SLAs and all. And so, I mean, there are more than 250,000 nodes that we have deployed. And this figure is, I'm sorry, there's a little old one. It will be somewhere around double or triple than what you can see over here as of today. So, and not so that was the routers. But once you have created a network, you need a management system which can manage everything, right from fault management to supervision of the network, to provisioning of the network, to you know uh, measure the utilization of the network, and to make operations life easy. So we have a product for network management as well. So this slide is typically showing the capabilities that you would need typically. And by the way, NMS is also covered. Network management system is also covered as part of the RDSO specifications that I shared in my earlier slides. So with that, sir, I come to an end of my presentation. Maheshwari ji, would you like to take over
Thanks,
from here?
Anandji. Thank you very much. But I would like you to be present here. Maybe Sachin, our engineer, will take about 5 to 10 minutes on the railway
Yes, sir.
solution,
Yes, sir.
and
I'm there.
then we will open for the queries from the various officers, because already in the chat a lot of queries have started coming. So be present there, please. Sachin, are you ready? Sachin Bajolia is one of the persons, sir, who is implemented MPLS for us 7 years back and is still with us. And he has also implemented Mehsana Patan and other places where he installed a lot of routers, a lot of SDH, STM, muxes. So he is a person who is understanding everything, whatever is required for this MPLS solution. So I think I have given a chance to him to present whatever is in his mind. Sachin, you take about 10-15 minutes max, please. Yes, your screen. आपकी screen दिख रही है सचिन? Voice नहीं आ रही है आपकी. Unmute करिए. सचिन, आपकी voice नहीं आ रही है. कौन सी? ये ऑफिस पावर ये वाला. ओके. यही स्लाइड है. नहीं नहीं, सबसे नीचे वाली. Sachin is here now. Just present.
Sir, can you hear me? सर
Yes,
जैसे
Sachin
कि
ji.
हाँ सर, जैसे रेलवे के नेटवर्क में जो अपना वीओआईपी बेस्ड ट्रेनिंग अपना ट्रेन कंट्रोल कम्युनिकेशन सिस्टम है, ये उसका जस्ट एक ब्रीफिंग है कि जैसे अपना इसमें डीटीएमएफ गेटवे, मेन सर्वर्स, टेस्ट कंट्रोल इक्विपमेंट्स, अदर एनएमएस सर्वर्स, वीडियो रिकॉर्डिंग्स, रेलवे एक्सचेंज, देन कॉर्ड पे जो इमरजेंसी कम्युनिकेशन गेटवे है, तो ये लैन पे जो अपना ट्रेन कंट्रोल कम्युनिकेशन सिस्टम है, ये लैन पे वॉइस गेटवे, एफएक्सओ एफएक्सएस गेटवे और कम्युनिकेशन गेटवे के थ्रू ये लैन पे आएगा। देन फिर इसका जो है अपना लेवल एज राउटर और एलएसआर और एलईआर पे ये कम्युनिकेट करेगा बीजीएफ के थ्रू। ये जस्ट एक रेलवे का जो मैंने बनाया है अपना डायग्राम, ये लेआउट एक जस्ट ब्रीफिंग के लिए बनाया है कि किस हिसाब से इसका कनेक्टिविटी होगा और इम्प्लीमेंटेशन होगा। फर्स्ट ऑफ ऑल जो जंक्शन पे लगेगा एलएसआर लगेगा, एलएसआर के बाद एलईआर लगेगा, उसके बाद सर इवन के थ्रू मक्स के थ्रू सारे डेटा लॉगर्स चैनल, स्काडा, यूएफएसबीआई, देन यूटीएन राउटर्स, L2 स्विचेस, देन अपना L3 स्विचेस और वीओआईपी के जो फ़ोन्स हैं, टेस्ट कंट्रोल रूम इक्विपमेंट्स हैं, ये सारे इसके ऊपर पूरा राउटिंग के हिसाब से पूरा चलेगा इसके ऊपर। ये इसके थ्रू E1 का कनेक्टिविटी है, ये LSR से 10G का बैकबोन OFC पे कनेक्ट होगा, LER से E1 के थ्रू अपना मक्स कनेक्टेड होंगे, देन ये डेटा लॉगर चैनल, स्काडा, यूएफएसबीआई, फिर इथरनेट पोर्ट्स के थ्रू लेयर 3 स्विचेस, लेयर 2 स्विचेस, देन लेयर 2 स्विचेस से फिर वीओआईपी गेटवेज, सिप सर्वर्स, रिकॉर्डिंग सर्वर्स, एनालॉग टेलीफोन्स, ये एमटीडब्ल्यू और जो लास्ट माइल इक्विपमेंट्स हैं वो सारे आईपी के थ्रू कम्युनिकेट होंगे। इसका एक ब्रीफ नॉर्मल एलईआर का जो डायग्राम्स हैं, ये नॉर्मल अपना जो यूटीएन राउटर्स लेयर थ्रू लेयर 3 स्विच से जो कनेक्टिविटीज़ होगी चैनल्स की, वो इस प्रकार होगी सर MPLS नेटवर्क में। सर इसके अब इसमें कोई क्वेश्चन आंसर या
और कोई slide?
नहीं
Any other slide?
नहीं
Okay. So Sachin is with us in the entire presentation now. So if now we are actually, I'll just summarize once this shit here. Okay. Okay. I'll just summarize the overall session, like what we wanted to achieve out of the session is, I think you have understood the basics of MPLS through Swamiji. Then we have understood various products with the help of NOKIA team, Bhatsab, Anandji and Rushit. And Sachin has tried to explain like how the connectivity will happen on the actual railway ground circuit. The overall, this MPLS technology will make railways on a very bigger height. I am confident about it because it's a proven technology as told by Anandji. It's a long used by all the service providers like Airtel and other. So it's there is no challenge in implementing MPLS overall. But the point is ki like how there is a lot of discrepancy in what will happen to the old system, SDH, STM. I think RDSO has very well defined the things and the architecture that how to phase out and how to come this new technology which will make Indian Railways the world leader, as we are already in a very good shape. So with the help of all these people in different categories, we have to design the system integration in such a way that this system should run for at least 20-30 years, not like every 5-10 years we have to change the technology. So the upgradability part we have to take care, as explained by Anandji, like the boxes should be upgradable. even if the budget does not permit in 1 year, I still have a suggestion like on a smaller station, we can start with switch initially, and on the bigger station, we can go for the routers. I still discussing that thing also. So a lot of things are there which we need to interact with all the team and make it a standardized solution. That is what RDSO specifies, that we should not change everywhere, like somewhere some configuration, somewhere some configuration. Then it will become a hybrid nature work. Of course, MPLS will run, but then again, it will not be a well-defined network. It will not called as a leader network. So something has to be brought out at the national level, which RDSO has already helped us. But still, I think there is a lot of discussions going on in various teams. I know of Western Railway at least. So let us come out with queries. Ashish ji, anything you want to conclude or anything you want to expect from us more right now?
माहेश्वरी जी, प्रेजेंटेशन वाज वेरी एक्सीलेंट। यदि किसी की कोई क्वेरीज हो तो वो या तो चैट बॉक्स में या माइक को अनम्यूट करके आस्क कर सकते हैं।
Or I'll just
सभी एक्सपर्ट्स यहाँ हैं ही। आफ्टर द
spell
क्वेरी
out my
सेशन वी विल
mobile. Yeah,
वी
I'll
विल
just
कंक्लूड।
spell out my mobile number at this moment because a lot of
ओके
people
ओके
may leave. So they can ask any queries to our team and we are open for that. So just
राइट
note
राइट
down my mobile number. It's 98270 39120. I'll repeat again, 98270 39120.
राइट।
Thank you. Thank you. Rushit ji, you want to say anything? While the time query is coming.
महेश्वरी जी नमस्कार।
नमस्कार।
सर एक क्वेरी है, जब अभी आपने लास्ट में स्लाइड दिखाई थी उसमें यूएफएसवीआई का नाम भी था, तो मैं ये जानना चाहता हूं कि क्या यूएफएसवीआई जो पॉइंट टू पॉइंट कम्युनिकेशन है या हमारे एक्सेल काउंटर वो भी पॉइंट टू पॉइंट कम्युनिकेशन है, क्या आईपीएमपीएलएस में किसी भी डिवीजन में क्या कार्य कर रहे हैं आईपीएमपीएलएस पर?
सर आईपीएमपीएलएस अभी तक किसी भी डिवीजन में लगा ही नहीं है।
ओके सर, तो
अभी तक
वेदर
किसी भी जगह पे इंस्टॉलेशन हुआ ही नहीं है। उसी के लिए काफी डिस्कशन चल रहा है। इनफैक्ट हम लोग भी इसीलिए पिक्चर में आए कि 4-5 महीने से हम देख रहे थे टेंडर्स आ रहे हैं, कैंसिल हो रहे हैं। सो दैट्स व्हाई वी टुक इंटरेस्ट एंड केमटेक हैज गिवन अस द अपॉर्चुनिटी टू इंटरेक्ट विद ऑल ऑफ यू टू कम आउट टू ए कॉमन सॉल्यूशन। आई वुड रिक्वेस्ट आशीष जी कि 1-2 हफ्ते बाद या 3 हफ्ते बाद फिर से एक और सेशन करें जो थोड़ा और एग्जॉस्टिव हो, तो जिससे अपन एक सॉल्यूशन पे भी आ पाए।
नहीं, गुप्ता सर, दिस इज सोहिल। Gupta sir, this is Sohil Vora from Baroda Division, Western Railway.
ओके सर।
सर जो आप पूछ रहे हैं वो बीपीएससी और जो इसको आईपीएमपीएलएस पे कर सकते हैं, तो सर वो डेफिनेटली सर पॉसिबल है, क्योंकि ये जो आईपीएमपीएलएस के जो एलईआर्स है, एलईआर्स के अंदर हमें इवन कनेक्टिविटी भी मिलेगी। तो जैसे कि इवन कनेक्टिविटी के ऊपर हमारे जो मक्स वगैरह चलते हैं, तो बीपीएससी और एक्सेल काउंटर को हम आईपीएमपीएलएस पे मक्स लेवल पे ले सकते हैं, या तो दूसरे जो मैपल फोर्स इक्विपमेंट्स आते हैं या तो मैपल जैसे दूसरे इक्विपमेंट्स हैं उसको भी सर अगर हम फाइबर कनेक्टिविटी दे दें या इथरनेट कनेक्टिविटी से दे दें, तो सर वो भी 64 केबीपीएस के चैनल पर इंटरफेस कर लेता है। तो वो भी सर मतलब कि उसके ऊपर हम ले सकते हैं मैपल कनेक्टिविटी के ऊपर भी।
एब्सोल्युटली अरोरा जी ने बिल्कुल सही बोला। वो मैपल के कनेक्टर से वी कैन, इनफैक्ट जो स्विच का सॉल्यूशन बीच में ला रहे थे वो भी मैपल के बेस पे ही ला रहे थे कि इवन कन्वर्टर्स लग जाएंगे तो सॉल्यूशन चल जाएगा। जो स्मॉल स्टेशन है जहाँ पे इतने बड़े इन्वेस्टमेंट की जरूरत नहीं है।
सर मैपल जो है, मैपल के अंदर इथरनेट कनेक्टिविटी भी आपको मिल जाती है, मतलब इट इज अ कॉन्फ़िगरेबल डिवाइस रहता है जिसके अंदर आप इथरनेट कनेक्टिविटी भी ले सकते हैं। और दूसरा 4 वायर के 4 सर्किट ले सकते हैं, 2 वायर के 4 सर्किट ले सकते हैं। तो बीपीएससी बेसिक है, तो बीपीएससी का ऑप्टिकल कनेक्टिविटी पे हम मैपल पे ले सकते हैं। गुप्ता सर,
अगर भोरा जी अगर ऐसा होता है तो आप जानते हैं कि आप तो चूंकि रेलवे से हैं, तो हम लोग सबसे ज्यादा हमारे यहाँ फेलियर और सफर करते हैं कि एक्सेल काउंटर फेल हो गया या यूएफएसवीआई फेल हो गया, हमेशा इसी मैक्सिमम फेलियर रिस्क होते हैं। तो अगर ये आईपीएमपीएलएस पे आता है तो इन केस ऑफ केबल कट, वेदर इट इज ओएफसी केबल कट और द 6 क्वाड केबल कट, our system will remain functioning very well. So
हाँ
if
एमपीएलएस बैकबोन के ऊपर सर वो हमेशा वो सर्किट हमें मिलता रहेगा, बट सर हमारी शर्त ये रहेगी कि हमने हमारे सिस्टम को उस हिसाब से ऑलरेडी कॉन्फ़िगर करके रखा हो।
तो मैं तो आपसे भोरा जी कहूंगा और महेश्वरी जी से भी कहूंगा कि जिस किसी डिवीजन में ये वर्क शुरू हो तो काइंडली सिग्नलिंग सर्किट को भी अपने आईपी एमपीएलएस जो सर्किट है उसके साथ इंटीग्रेट करें, बिकॉज झांसी में भी जो 6 पोर्ट मैपल का आप जो बात कर रहे हैं उसमें 6 पोर्ट हमारा सिग्नलिक्स का या सिग्नस का 2 पोर्ट का चेंज ओवर लगा रहे हैं हम, बट वो जब भी ओएफसी केबल कट होगी या क्वाड दोनों कट जाएंगी तो हमारा सिस्टम तो फेल हो नहीं है। तो अगर हमें आईपीएम एमपीएलएस से ये हमें डिफरेंट नेटवर्क मिल जाएंगे या पाथ रिडंडेंसी मिल जाएगी तो हमारे लिए बहुत अच्छा होगा। फेलियर हमारा ब्लॉक का और एक्सेल काउंटर का 0 हो जाएगा। आई थिंक सो।
हम सर वेस्टर्न रेलवे में जो आईपीएमपीएलएस प्लानिंग कर रहे हैं सर, हम उस टीम के हिस्सा हैं सर। तो बेसिकली हम उस चीज को भी बहुत ही मतलब कि अच्छी तरह से उसको फोकस कर रहे हैं। मतलब आप तो सिर्फ बीपीएससी एक्सेल काउंटर की बात कर रहे हैं, हम तो डेटा लॉगर्स को भी उसके अंदर इंटीग्रेट करेंगे। डेटा लॉगर्स हो गया, देन ब्लॉक हो गया, देन दूसरे जो आपके एचएस डीएसीएस रह गए। मतलब हमने सिग्नलिंग सिस्टम्स को भी इसमें बहुत अच्छी तरीके से इंटीग्रेट करने का पूरा प्लानिंग मतलब हम लोग कर रहे हैं मिलके।
ओके ओके, वेरी गुड।
Excuse me, I have one more query. I'm from Jhansi Division, Senior DST. मेरा क्वेरी एक्चुअली ये है, सपोज इफ वी शिफ्ट आवर सिग्नलिंग सर्किट टू दैट MPLS, so if in case my station to station OFCs get cut due to any excavation work, so MPLS automatically वो path divert कर देता है, but how much time it will take to switch the path to different direction?
I think I know the answer, but Anand ji, please.
हाँ सर, सो डिपेंड करता है कि आपका जो आपने जो नेटवर्क जिस तरह से डिजाइन किया, ऑफ कोर्स आपके पास में रिडंडेंट फिजिकल पाथ तो होना ही चाहिए एंड वो आइडियली डाइवर्स होना चाहिए। सो मैं जैसे इमेजिन करता हूँ कि मैं एक स्टेशन पे हूँ, मेरा डाउन ट्रैक पे मेरा एक ओएफसी रन हो रहा है और अप ट्रैक पे मेरा मेरा ओएफसी रन हो रहा है। एंड टिपिकली मेरे अगर दो दो एलईआर अगर लगे हुए हैं या अगर एक एलईआर है, तो अगर मेरा डाउन साइड का फाइबर कट होता है तो अप साइड में स्विच करने में with the kind of protocols that we have in IPMPLS, जैसे RSVP है, ट्रैफिक इंजीनियरिंग है, ओके, मैं डिटोर पाथ बना सकता हूँ। टिपिकली सब 50 मिली सेकेंड्स जैसा टाइम भी मिलता है, सब 50
Actually,
मिली सेकेंड्स।
मैं इसलिए पूछ रहा हूँ because our signaling circuits जो है they are very time sensitive. If for couple seconds if the circuit the continuity is not made, so it will fail. Especially
सर
that
इसको
accel counter and block. So
जी
communication
जी
error will come. So that's why
सर
I
मैं
was asking कि how much time it will take for switching from one part to the
जी
another part.
सैनी सर, मैं इसको ऐसे रिलेट करता हूँ कि जैसे कम्युनिकेशन सर्विस प्रोवाइडर्स हैं जो, ठीक है, जो कि जैसे 3G है या 4G टेक्नोलॉजी है, इसमें भी क्या होता है कि जो रेडियो सेल साइट होता है, ठीक है, उसका अपने कंट्रोलर जो एमएससी होती है या जो बीएससी होती है, ठीक है,
जी जी
उसमें भी इनका सिग्नलिंग होता है, सिग्नलिंग प्लेन होता है और डेटा प्लेन होता है। डेटा प्लेन
yes
टिपिकली आपका वॉइस पैकेट्स को कैरी करता है और सिग्नलिंग प्लेन ये दोनों के मतलब रेडियो जो रेडियो साइट होती है, सेल साइट,
जी
जो बीटीएस लगा होता है या फिर जो बीएससी होती है या एमएससी होती है, इनके बीच में हार्ट बीट्स एक्सचेंज होती हैं सिग्नलिंग के थ्रू। वो लोग भी
yes
बहुत ज्यादा सेंसिटिव होते हैं कि अगर उनका सपोज 1-1.5 सेकंड के ऊपर अगर उनका कम्युनिकेशन नहीं हुआ तो आपकी जो कॉल्स चल रही हैं वो भी ड्रॉप हो जाती हैं, राइट?
जी जी
एंड देन उनके लिए वो रेवेन्यू इम्पैक्ट है,
Okay.
मोबाइल ऑपरेटर्स के
So
लिए।
any trial has been done so far, especially for the signaling circuits of railway? Yeah, we have to try to make some trials in future.
सर देखिए, जैसे जैसे महेश्वरी सर ने भी बताया कि अभी तक तो रेलवेज ने आईपीएमपीएलएस नहीं किया है डिप्लॉय
Yeah,
कहीं पे भी,
yeah,
तो
yeah.
उसका तो एग्जांपल नहीं मैं बोल पाऊंगा, बट हाँ ग्लोबली बहुत सारे रेलवेज हैं जिन्होंने आईपीएमपीएलएस को एज अ टेक्नोलॉजी अडेप्ट किया है एंड काफी सक्सेसफुली। एंड उसमें काफी सारी चीज, नॉट ओनली मैं ये नहीं कहूंगा सिर्फ उसमें डेटा ट्रैफिक चल रहा है या नॉन क्रिटिकल ट्रैफिक चल रहा है, उस पर क्रिटिकल वॉइस ट्रैफिक, सिग्नलिंग ट्रैफिक, ये सब भी चल रहा है।
Okay.
So we can probably bring some references for that.
Okay. Okay. Thank you.
जी सर.
चैट बॉक्स में भी कुछ क्वेरीज हैं माहेश्वरी जी, हो सकता है शायद वो.
सर वो सचिन की पीपीटी बोल दिया, सचिन को
ओके,
कर देगा। और एक और क्वेरी थी पहले, वो रुचित जी ने आंसर कर दी थी। उन्होंने पूछा था कैन IPMPLS एड्रेस द वाइटलिटी ऑफ सिग्नल गियर्स which have zero tolerance towards false fit. So question was very tough, but Rushit already answered yes. And my team has replied, I'll just spell out. Since LER is simply aggregator, what comes on signaling is put back on the network. Signaling network should already have mechanism to stop false fit. That is also correct. Actually in both way, signaling तो सिग्नलिंग वाला ही हैंडल करेगा, मतलब इन द सेंस कि उसका ही मैकेनिज्म हैंडल करेगा. MPLS will not do anything in that, but MPLS will not harm anything in that.
So basically MPLS जो है it's just a transport technology. सर
it will
ओके,
not
जो
harm.
SDH ईरा में क्या होता था, आप बेसिकली स्टैट्स गेन का बेनिफिट नहीं लेते थे जो आप टिपिकली ईथरनेट डोमेन में ले सकते हैं. तो फॉर एग्जांपल आपने ए एंड से बी एंड के लिए आपने कुछ 8-10 इवेंट्स प्रोविजन करके रखी हैं, तो वो उसमें से चाहे 4 यूज हो रही हो ना हो रही हो, वो 8 की 8 हमेशा वो बैंडविड्थ रिजर्व रहेगी. ईथरनेट ने सबसे अच्छा काम जो किया था, ईथरनेट ने वो ये किया था कि आप कम प्रोविजन करें और ज्यादा को सर्व करें, ज्यादा लोगों को सर्व करें. बिकॉज ये आइडिया बहुत अच्छा है कि सबके सब एक साथ में बात नहीं कर रहे, नॉट एवरीबडी इज टॉकिंग एट द सेम टाइम. तो why to reserve bandwidth for all the people in the room when only few are talking at a given point of time in the day. सो स्टैटिस्टिकल गेन, मल्टीप्लेक्सिंग गेन जो है वो IPMPLS में बहुत अच्छा है कंपेयर टू SDH और TDM. बट देन अगेन बोथ आर इवन. SDH में आप क्या कर रहे हो, सिग्नलिंग आप जो आपके एंड टर्मिनल्स हैं जो कि वो सिग्नलिंग आपस में कर रहे हैं, SDH हो चाहे APMPL हो, दे आर ट्रांसपोर्ट टेक्नोलॉजीज. वो उनके पेलोड को खोल के उस पर डिसीजन नहीं कभी लेंगे, वो उन्हीं को हैंडल करना है. बट हाँ, वो उनको जो जो उनकी लेटेंसी रिक्वायरमेंट है या उनकी जिटर रिक्वायरमेंट है या उनकी कन्वर्जेंस टाइमिंग्स हैं या उनकी क्वालिटी और सर्विस रिक्वायरमेंट्स है, वो उसको फुलफिल करते हैं. दैट इज द नीड, दैट इज द पर्पस ऑफ द, दैट इज द जॉब ऑफ द ट्रांसपोर्ट नेटवर्क. एंड एप्लीकेशंस दे हैव टू, उनके जो प्रोटोकॉल्स हैं, उनके जो कम्युनिकेशन मैकेनिज्म है, दे हैव टू टेक केयर ऑफ दैट.
It's not actually part defined technology na, like SDH. So I want to just address the earlier query also. Europe Railway is already working on MPLS, and normally the time is in milliseconds. So the question earlier Seni Saab has asked now. ठीक है सर.
एनी फर्दर क्वेरीज और
सर
किसी की हो तो.
क्या सोहेल जी बोल रहे हैं कुछ?
ठीक है सर, कंक्लूड करते हैं फिर, और नहीं हो तो.
कह रहा था
हाँ सोहेल जी, कोई क्वेश्चन हो तो पूछ लीजिए.
हाँ सर, मैं ऐसा कह रहा था कि मतलब जैसे कि महेश्वरी जी ने अभी वो यूरोपियन सिस्टम का एग्जांपल दिया, पर ये भी एक ये होगा, मतलब एक सर्वे करने का या तो एक एक्सप्लोरेशन देना होगा कि मतलब यूरोपियन रेलवेज में भी क्या एक्सेल काउंटर्स वगैरह अभी भी वर्किंग में है क्या, क्योंकि वहां पे कौन सी टेक्नोलॉजी अभी चल रही है वो देखना पड़ेगा ना सर.
Yes, you're right, sir. You're
उसके
right.
लिए यूरोप का एक टूर कर
They
लीजिए
have
रेलवे की तरफ
generally
से.
shifted to the IP technology, like metro train. Even in India, if you see metros are started shifting completely to the IP and the switching. Matlab, even in India. So you are absolutely right. That has to be cross-checked, but they might not be using it all.
They may be using the moving block technology.
They have automatic signaling tech system, na sir? Thank you, Ashish ji.
ठीक है, कंक्लूड
I
करते हैं
think,
सर
I
फिर.
think we should, yeah.
थैंक यू मिस्टर माहेश्वरी जी एंड मिस्टर स्वामी जी, Mr. Sachin
Sir,
ji
and we
from.
are open for further discussions. We
Okay.
should, sir.
So from Messrs. Maheshwari Computer, and I will also like to thank Mr. Anand and his team from Nokia for the excellent presentation. So I also thank on behalf of Chemtech to all other participants and senior officials also who gave their valuable time for the webinar. I will request all to please give their feedback on the webinar. The link of the feedback is given in the chat box. So I request all participants to please give their feedback through that link. And thank you.
शेयर कर दीजिए.
हाँ, वो भी शेयर कर देंगे.
Thank you everyone.